Good morning. In this video, we will discuss some exercise on normalization. Okay, let's see the question 1. Assume that the following table contains the details of students. Check whether the below table is in first normal form or not. Justify your answer. If the table is not in first normal form, then normalize the table. Include the proper table name, attributes, and the indicate the primary key and all. So let's look into the student table. Student table contains 5 attributes: student number, name, major, country, phone number. Look into the attribute phone number. It is a multi-valued attribute which is called non-atomic attribute. If a table is in first normal form, then all its attributes should be atomic attributes. But here, phone number is a non-atomic attribute. So, this table is not in first normal form. Okay. So, the question says, if it is not in first normal form, then normalize the table. Okay, just normalize it to remove the multi-valued attributes. Okay, not removing, to give a solution for the multi-valued attributes, atomic. How? Split it into 2. For example, this phone number, it can be uniquely identified by the primary key, student number. So, student number with the phone number. You move it into another table. Just call it contact table. And the other attributes, student name, major, country, which are uniquely identified by the student number in the student table. Okay, so the primary key student number uniquely determines the name, major, country. So student number is the primary key in the student table. Okay, in the contact table, the student number is a foreign key, references the student number in the student table. It's a foreign key. Okay, in the contact table, student number is a foreign key, not a primary key. Okay. Now, let's look into another exercise. Assume, actually it's a student table. Okay. Assume student table as given below. Check whether the below table is in second normal form or not. So, the similar type of question, but this time second normal form. Look into the student table. It contains 4 attributes: student number, subject ID, mark, teacher name. So, the records are not given, but logically speaking, these attributes are atomic. There is no multi-valued attributes. All the 4 attributes of the student table are atomic. When a table contains all atomic attributes, it's in first normal form. Sure. How about second normal form? Look into the dependency, functional dependency. Student number and subject ID uniquely determines the mark. How about the teacher name? Only the subject ID can be determined teacher name. Okay, so it's possible to have one attribute, one primary key attribute. Okay, like the key attribute, subject ID, it can uniquely determine the teacher name. This is what we call partial dependency, not the full dependency. Okay, just the subject ID can uniquely identify the teacher name. It's possible. So this is called presence of partial dependency. So when there is a partial dependency, I can say this table is in second normal form. It is not in second normal form because of the existence of partial dependency. So the question says, if it is not in second normal form, normalize the table. So just now we say subject ID uniquely determines the teacher name. So move it into a new table. Can you see here a teacher table? Subject ID is the primary key and it uniquely determines the teacher name. Fine. How about these two marks? Student number and subject number uniquely determines the marks. Okay, fine. So these are the two tables. So here, subject ID in the student table is a foreign key that references the subject ID, primary key of the teacher table. Okay then, so this is the relationship between the two table. So subject ID in the student table references the subject ID in the teacher table. So this is the reference. Okay, let's look into the third exercise. Assume the following score table as given below. Check whether the below table is in third normal form or not. Okay, so let's look into the score table. It has 5 attributes. By looking into the attributes without the data even, logically speaking, all the 5 attributes are atomic. Okay, no multi-valued attributes. So I can say it's in first normal form. And look for the functional dependency. I didn't see any partial dependency. Partial dependency means, let's look into it. Student number and subject ID uniquely determines the mark, course type, and then ceiling. Okay, so here I can say that um, there is another dependency exists here. Course type uniquely determines the mark ceiling. So that means this functional dependency here, what we have here, it looks like A derives B and B derives C and then A derives C. That's the thing. Okay, for example, can you see here, student ID number, subject ID number uniquely determines the course type, and the course type uniquely determines the mark ceiling. Can you get the idea? So this is what we call um, transitive dependency. Okay, so A derives B and B derives C. That means in turn A derives C. Okay, so the presence of transitive dependency concludes that this table is not in second normal form. Obviously, it's not in second normal form. Okay. So the question says you just normalize the table. So how do we normalize the table? We just now say that course type uniquely determines the mark ceiling. Move it into a separate table. Can you see exam table? Course type uniquely determines the mark ceiling. And then the rest, student ID number and subject ID number, it uniquely determines the mark and then the course type. Okay, so this is the student score table. Okay, so there is a reference here. Course type in the score table, it's a foreign key that uniquely references the course type in the exam table. The reference, primary key, foreign key references. Now another exercise. Assume the following student table. Check whether the table is in third normal form or not and justify your answer. Okay. This is the student table. It has 5 attributes. By looking into the attributes, all of them are atomic attributes, no multi-valued attributes. So I can conclude it's in first normal form. I didn't see any partial dependency. So it obviously in second normal form. There is a dependency missing in this diagram. City derives country. It's missing here, but the dependency is, the arrow is missing, but you can keep it in mind. Okay. So here there is a transitive dependency. What is it? Student number uniquely determines city. City uniquely determines country. So A derives B, B derives C, and in turn A derives C. Something like that is it. This is what we call transitive dependency. There is a presence of transitive dependency. By the way, the dependency city derives country is missing here. Okay, I forgot to mention it. So just keep it in mind. So here you just see a transitive dependency. So we can conclude this table is not in third normal form. So the question says split the table. So when you split the table, city derives country. So move the city and country in a separate table. Call it country table like here. The other attributes, keep it in the student table, which is student number, name, city, and then age. Okay. So here, city in the student table uniquely, references the city in the country table. So foreign key, primary key references. City in the student table is the foreign key. City in the country table is the primary key. Okay, thank you.